The dandelion, Terex cum officinale, is a plant that really needs no introduction. With thanks as always to human intervention, the dandelion has succeeded in near global conquest, and it occupies our hearts and minds just as much as it does any physical space. In all likelihood, the first plant you were able to recognize in life may well have been a dandelion. They have charismatic blooms, their seed heads grant wishes. You get the picture. But the thing worth mentioning about dandelions, which may not be obvious on first blush, is that they aren't flowers. Or at least, not exactly. Now, I like to imagine you're a savvy viewer. You've probably at least seen half of the video essay before, so you've likely picked up on the little lie by omission that I'm doing, and I assume you're expecting the prestige where I suddenly lift the curtain and reveal this video is actually about semiotics. Well, no, or at least not as such. See, the twist is actually much simpler than that. A dandelion isn't just a flower. It's actually closer to around 200. A dandelion head is actually a prime example of what botanists call a capitulum, a dense aggregate of individual florets that altogether coincidentally resemble a single flower. And it isn't unique to dandelions either, but is instead a representative trait of their respective family, Asteraceae. Now, whether or not you know to call them by that name, you're undoubtedly familiar with the asters. Asteraceae is the largest circumscribed plant family, with over 32,000 species, belonging to over 1,900 genera. And unlike its closest rival Orchidaceae, you'll find asters across the gradient of human habitation, from alpine peaks all the way down into city subdivisions. And the capitulum plays no small role in this conquest. If you choose to look at trends in floral structuring in terms of reproductive efficiency, and listen, that's a flawed approach, but you do you, then asters basically occupy the zenith of this whole progression. But compound and pseudanthial structures are nothing new when it comes to floral evolution. Capitular structures have even evolved independently in families like Dipsaceae and Proteaceae. What makes asters different, however, is their family-wide adoption of this structure, and the evolutionary extents they take it to. If you'll allow me a moment to spout off some esoteric taxonomy facts, Asteraceae is one of a handful of cosmopolitan plant families that used to go by a different name. We'll get to the others eventually, I'm sure, but these families were named for a distinguishing morphological feature as opposed to a representative genus or species. Asteraceae's old name, which you might still see in certain guidebooks, was Compositae, referring of course to their composite flowers, the capitulum. And taking a closer look at these flowers, some discernible patterns begin to emerge. See, the capitulum can generally be divided between two types of florets: ray florets, which line the perimeter of the composite, and disc florets, which are packed tightly into the center. Since florets are evolutionarily minimized flowers, you can still see most of the floral structures still intact. And one of my favorite things about ray florets are their petals. I guess the technical term is a ligule, but come on, they're petals. Since these are individual flowers having undergone a degree of floral fusion, you can still make out the seams where each petal would otherwise separate. It's a delightful little relictual feature. It's one of those things that I just love about botany. But regardless of that, these florets all connect to the central receptacle and are enclosed by an envelope of floral bracts, botanically known as an involucre. And across the family, you'll see these themes in variation. There are asters with only disc florets, or a disproportionate number of ray florets. It's a big family. There's room for improvisation. But for the most part, these are the general building blocks of an aster. But as is the case with a lot of characteristic and revolutionary plant adaptations, we don't fully know how the capitulum evolved. The earliest known aster fossils are pollen grains from Antarctica, dated somewhere around 76 to 66 million years ago, but the age of the family has been re-estimated to 83 million years ago. Still pretty recent in terms of angiosperm evolution, but much older than previously thought. And for a geological point of reference, 66 million years ago was the KPG extinction event, the Chicxulub impact. So the basalmost asters were kicking around in the time of the dinosaurs, and the family really began to diversify well after their extinction. And for what it's worth, this doesn't appear to be a chicken and egg kind of scenario. From the knowledge we currently have at our disposal, for as long as there have been asters, those asters have had capitula. with even basal clades in the family like Barnidecioideae demonstrating clear capitular structures. They're, a little different, a little more primitive, but those are still capitula. But I can't emphasize enough that this is really weird. For an at best occasional morphological feature to see full family wide adoption from the jump? That really isn't par for the course in the botanical world. These things take time to evolve. And for a family to just come out the gate swinging, that's unusual. And so, while yes, the composite is a characteristic feature of Asteraceae, current literature indicates that this specific morphology has been cooking in the background for quite some time. And to help illustrate that, I'd like to introduce you to a couple other families. Alright, so, in the wider order of Asteraceae, there is a group of plant families pretty closely aggregated amongst each other because botanists generally tend to agree that, they're pretty closely related. This is known as the MGCA clade, short for Menanthaceae, Goodeniaceae, Cheliceraceae, and Arpalasteraceae. If you've never heard of these three other families, no one's really going to hold that against you. Menanthaceae is distributed worldwide, but it isn't a very speciose family with only 60 to 70 members. Goodeniaceae is a little larger at around 404 species, but these are almost all native to Australia, and Cheliceraceae is similarly restricted to South America, so clearly Asteraceae's penchant for wanderlust isn't exactly shared among its immediate cousins. But nonetheless, to both botanists and a handful of canny observers, the relationship among these families is pretty clear. And when we examine floral trends among these families in a process known as phylogenetic character mapping, we can kind of make out a lineage of floral morphologies that leads us, eventually, to the capitulum. Now, as you might expect, members of the MGCA clade tend to display pretty intricate inflorescence structures. What we tend to see most among these families are botryoid and thyrsoid shapes, and thyrses are especially notable because while the main axis is indeterminate, the subaxes, which include the actual floral clusters, are themselves determinate. And I don't know about you, but this strikes me as a pretty clear precursor to the determinate capitula of Asteraceae. Of all these families, Cheliceraceae is the most phylogenetically adjacent to the asters, and in this family we tend to see the most striking similarities in terms of inflorescence shape. Members of Cheliceraceae have cephalioid inflorescences, which are essentially botryoid and thyrsoid structures if you just smushed them down a little bit. And from here, the only real evolutionary boundary between these cephalioid structures and a true capitulum are a series of structural reductions in the inflorescence's evolutionary development. And, of course, we may never know the missing link between Cheliceraceae and Asteraceae, but this is the current picture as best we can surmise it. Also, this is a little bit of a side tangent. I don't really know how to fit this into the script, but one of the 8 genera in Cheliceraceae, and one of the model genera in this paper that I'm using for reference in this video is called Buppus. It's called Buppus, and I can't convey to you the experience of reading this dense academic paper with a heap of esoteric lingo that even I'm not really fully used to, and out of nowhere they hit you with Buppus, and you have to take a couple seconds to recover every time. And this is another digression, but since I'm a sucker for weird somatic nonsense, I'd be remiss not to mention capitular fasciation. So fasciation is a type of altered growth pattern that happens to meristematically derived cells. It happens to stems, it happens to flowers. I've never seen this personally, but it probably happens to roots as well. There can be a variety of underlying causes to this, but when cell signaling pathways get interrupted in a dividing meristem, the resulting organ divides laterally instead of vertically, producing strap-shaped or sometimes even ribbon-shaped complexes. I've seen a few examples of this in situ, and for whatever reason, it always seems to be in aster flowers. I'm not totally sure why composites are more inclined to do this, but I would assume it's probably because they're determinately matured organs with really complicated cell signaling pathways behind their maturation. And now, like I said, I imagine you to be a savvy viewer, please don't prove me wrong on that, so you might have already noticed the hemispheric trends in aster evolution. Between the Antarctic pollen grains, the generally pantropical distribution of the MGCA clade, and the basalmost subfamilies of Asteraceae being largely South American, the evidence really skews in the direction of the family evolving on a still intact Gondwana, with the more recent groups diversifying from there. And obviously, the capitulum plays a major role in that spread. I've just spent a nondescript amount of time detailing our best guess as to how that shook out. But across the family, we find a whole host of other adaptive mechanisms that also give Asteraceae a potential evolutionary advantage. First off, in phenological terms, the asters mostly have very brief life cycles. They're largely herbaceous annuals or biennials, which helps hasten the rate of generational change. They're also a diverse bunch metabolically speaking, boasting a wide panel of secondary defensive compounds. Instead of starches, the asters are more prone to store their energy in fructan compounds, such as inulin, which confers a degree of tolerance to frost or drought and plays an advantageous role in xeric or transitional environments. And morphologically, a variety of species are known to display heterocarpy, the alteration of fruit morphs in response to environmental conditions. In nearly all ways, Asteraceae is a family more or less primed for world domination. And there's nothing necessarily wrong with this. In a vacuum, this is all well and good. But people have a way of complicating things, and when you transfer a plant so effectively suited to thrive in one environment, and you transfer it to a similar biome on, let's say, another continent, that plant can leave a disastrous impact on its new home. And let's return to the dandelion, which is kind of a best-case scenario when it comes to invasive ecology. There's an ongoing debate as to whether or not it's nutritionally sufficient for America's native pollinators, but for now, and on a case-by-case basis, it's more or less innocuously naturalized on the American continents. But the dandelion is just one of many transcontinental asters, and they're not all such polite house guests. And this isn't to imply that composites are uniquely invasive in any way, but I think it's worth mentioning the role human involvement, and especially unconscious human involvement, has played in the domination of weedy asters, especially when it comes to their preferred environments, whether it's dandelions or salsify or knapweed or musk thistles. These plants all tend to thrive in disturbed industrial or interstitial soils, environments we make almost as a byproduct. And if these are what we cultivate on accident, imagine if we counterweighted that with more intention. And what I guess I'd like for you to take away from this is that if you live somewhere on Earth, and I'm assuming you do, odds are you've got a couple native asters within driving distance. And the first step in protecting your local flora will always be to learn about them. So I want you to find a guidebook or a local expert, go get some sunlight, and find an aster. You'll be glad you did.